In this video we start looking at the measures of spread. So we've already looked at the measures of central tendency. So those were one value that allow us to make a sort of summary of all of the statistics. Now we start talking about how spread out the data are. So we'll have a look at some examples here. The first thing we're going to talk about today is the range. So the range is the easiest measure of spread to calculate. It is just the difference between the highest value and the lowest value. So let's say we have a few values here. Let's say 20, 21, 24, and 29. So it's a very small data set. The range here is just the difference between the highest and the lowest. So the range in this case is equal to 29 minus 20, which is equal to 9. So again, the range just tells us how spread out are the data in total. We should talk a little bit about the median, because we're going to talk about the interquartile range, and in order to do that we need to understand a few things. So just a reminder, the median is the middle value when the data are sorted from lowest to highest. So again, if we do a quick little example, if we say that there are some data here, 1, 1, 3, 5, and 7. There are 5 pieces of data, and in order to find the middle, we can take those 5 pieces of data, add 1 to it, and divide by 2. So 5 plus 1 is 6, divided by 2 gives us 3, which tells us that the third data piece is actually the median. So that's the median in this case. Now the reason why we review the median here is that we are going to talk about quartiles. And a quartile, or quartiles in general, divide the data into quarters. So it's like the median, where the data has to be organized from lowest to highest. The difference is that instead of dividing the data into 2 pieces, we divide the data into 4 pieces. We call these different pieces quartiles, and we say that Q1 is the first quartile, and Q3 is the third quartile. You might be wondering what happened to Q2. So if we just imagine the data being spread out on a line, we talked about the median being the middle. The first quartile, Q1, is the first quarter. So the first quarter of the data would lie to the left of Q1. Q3 is the third quarter of the data, and I think maybe you can sort of piece together what happened to Q2. So this is Q3 is this value here. So again, a quarter of the data, so this is 25% of the data lies here, 25% of the data lies here, and Q2, we have another name for it, we just call it the median. And again, each one of these sections has 25%. So Q1 is just the median of the first half of the data, and Q3 is the median of the second half of the data. So if we know how to calculate a median, or find a median, then we can find the quartiles. Now we use the quartiles for the interquartile range. Typically we'll just abbreviate that as IQR for short. The interquartile range is like the range, but it's the range between Q1 and Q3. So if we look at Q1 and Q3, the interquartile range is the range here. And why this is important is that this is the middle 50% of the data. So just a reminder, we have 25% of the data in here, 25% of the data in here. So the reason why the interquartile range is useful is that it gives us sort of the range on which the middle half of the data lie. So that's what interquartile range is. We find Q1, we find Q3, we subtract Q1 from Q3, and that gives us the interquartile range. Let's have a look at an example. So here's an example. This example contains 20 numbers. We're going to start by finding the median. So if there are 20 numbers, we want to look at the 20 numbers. We'll add 1 and divide by 2, and that tells us where our middle datum is. So 20 plus 1 is 21, divided by 2 is 10.5. So we're looking for the piece of data that's between item number 10 and item number 11, and I think that happens right in here. So let's just double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It does. So this is the midpoint between the two. So the median is just the average between those two data points. So the median here is going to be 5 plus 6 divided by 2. I know you probably don't need to see this written down, but we'll do it anyway. So 11 divided by 2 is 5.5, so that gives us the median. So now if we're looking for the Q1, we need to look at the median on the first half of the data. Well, the first half of the data is right here. There were 20 numbers in total. There are 10 on the leftmost side. So again, 10 plus 1 divided by 2 gives us 11 over 2, which is 5.5. So we're looking for the average between the 5th and the 6th. So 1, 2, 3, 4, 5, and 6. That's right in here. So Q1 falls right between there, while the average of 3 and 3 is just going to be 3. So Q1 equals 3. Q1. Let's fix that up. And then we do the same thing for the second half of the data. So again, the second half is the last 10 numbers. So these 10 numbers make up the second half. And again, we're just going to find the median. We've already figured out that we need sort of the average between the 5th and the 6th element. So 1, 2, 3, 4, 5. Q3 is right in here. So Q3 is equal to 10. And if we're going to find the interquartile range, so the interquartile range is just the difference between those two. So 10 minus 3, which is equal to 7. So we say that the interquartile range is 7. That means that in this little section from here to here, half of our data lies within 7 points of each other. So that's why an interquartile range might be useful. There is something called the semi-interquartile range, where you can kind of just take half of it, so you know how far either side of the middle that you can go to. But it's kind of not really what we're talking about today. But if you do hear about semi-interquartile range, it's just half of the interquartile range. Now, one thing that we might want to talk about here is to illustrate this with a graph. And we can illustrate this with what we call a box and whisker plot. So I'll just write the name down here so you don't forget it. A box and whisker plot. It's a type of graph. It kind of looks like this. It's called a box and whisker plot because essentially it is a box. That's not a very good looking box, but hopefully you get the idea. And the idea with the box here is that the values, or the ends of the box here, so this right here and this right here, end up being our quartiles. So this is Q1 and this is Q3. Sorry, I forgot a 1 here. And in the middle somewhere, we put the, I shouldn't say in the middle because it's not necessarily in the center. It is designed to be done on a scale. So we know, for example, that our interquartile range is 7. And so if our interquartile range is 7, then this distance in here should represent 7 units. Well, we'll just kind of do this rough so you get an idea of what the box and whisker plot looks like. So Q1 was 3, so this value is 3. Q3 was 10. And our median, which was somewhere in between there, our median was 5.5. Well, 5.5 is closer to 3 than it is to 10. So we show the box and whisker plot with a line inside the box indicating where the median is. So there's the box part of our box and whisker plot. Now the whiskers are used to show the rest of the data. So coming out of our box and whisker plot, we have the whiskers. So half of the data is within this box. And then we have the whiskers coming out here. They are supposed to be straight lines. I've gone a little bit far here, so I'll just backtrack a little bit. And they just show, I'll see if I can get a straight line too. They just show how far the data goes to the lowest point and the highest point. So here, the lowest point was equal to 1. So that's just the lowest value in our set of data. And the largest data point was 30. Well, 30 is quite a bit bigger than 10. So we get this box and whisker plot that looks something like this. So the whisker on this side is much larger because the distance between the smallest point and Q1 is much smaller than the distance between Q3 and the largest data point. Now, I'm going to talk a little bit about outliers. Let me just ignore the outliers for now. Some of you may have heard of outliers and how they kind of play into this. This point 30, this data point of 30, is quite far from all of the others. And in fact, we might say that it's an outlier. What that means is that it's quite far from all the rest, and it's considered to sort of be a little bit of an anomaly. So in this case, the way that we determine whether something is an outlier is, and I'll write this down so you have it here, is that it's an outlier if it's more than 1.5 times the box length away from the edge of the box. So here's the length of the box, which is the interquartile range, and if we're more than 1.5 times that value from the edge of the box, then it's considered an outlier. And typically we would show an outlier as just a dot. So if the whisker kind of went a certain distance, we'd have a dot further along. So I'm just going to check here. If we do 5.5, that was our interquartile. Oh, sorry, our interquartile range wasn't 5.5. Our interquartile range was 7. So if we do 7 times 1.5, we get 10.5. So anything that's more than 10.5 beyond the edge here, so anything that's beyond 20.5 is considered to be an outlier. So this 30 is in fact an outlier. And the way that we show that with our box and whisker plot is we don't go all the way to 30. We'll go to the next data point. Because that second data point, it's possible that it's an outlier, but in this case it's not, because it's not more than 1.5 times the box length away from the edge. And I'll explain that in just a second here. So we've got our 16 was here, and 30 would be much further, and it's going to be an outlier. So it kind of sits out here. Oh, sorry, I should change my pen color to match the rest. So it sits, let's try that again, sits out here, all on its own. So I'm just going to jot this down here. Outliers are more than 1.5 times away from the edge of the box. 1.5 times the box length away from the edge of the box. And if we wanted to sort of get more technical with our definition, anything more than 1.5 times the interquartile range away from Q1 or Q3 is considered to be an outlier. So in our case, the interquartile range was equal to 7, so that's the length of the box. 1.5 times 7 is equal to 10.5. And so anything that's greater than, and I should say we should look on both sides of the box. So we should look on this side and on this side. It's pretty obvious from this data set that the 1 is not an outlier, but we should check anyway. So I'll just show you what that looks like. Q1 was 3. So if we do 3 minus 10.5, you can see obviously the answer is going to be negative. We didn't have any negative values. We get negative 7.5. So anything less than negative 7.5 would be considered an outlier. We don't have any of those, so there's no worries there. And then we also look at Q3. So this was for Q1, and then we also look at Q3. So for Q3, we're looking at here we're looking at adding on to Q3. So Q3 was 10. So 10 plus the length of the box is 10.5, which gives us a total of 20.5. Anything greater than 20.5 is an outlier, and that's why 30 is an outlier here. So that's a quick, well, maybe not so quick, demonstration of the box and whisker plot. It's a fairly simple graph. One of the things that you want to try to do is try to make sure that the scale is preserved throughout. And hard to do without a grid paper or something like that. But try to make sure that the scale is represented. The bar in the middle for the median, right in here, doesn't go in the middle. It goes wherever this value, our median was 5.5, wherever the value of 5.5 should lie along your scale. All right. Let's do one more quick example of interquartile range. I wanted to show this one because it actually has an odd number of data points. 2, 4, 6, 8, 9 data points. So again, we're going to find the median. And the median is the middle value. If there are 9 data points, 9 plus 1 is 10 divided by 2 is equal to 5. So the fifth one should be our center. 1, 2, 3, 4, and 5. I maybe miscounted. 1, 2, 3, 4, 5, 6, 7, 8, 9. And we've got 1, 2, 3, 4, 5. I did miscount. So let's just back up a bit. So 1, 2, 3, 4, and 5. Alright, so there's our center right there along. Let's see if I can highlight that. Our center is right here. We have 4 numbers to the left, 4 numbers to the right, and now we repeat the process. So that is our center. So we look at what's to the left. Well, there are 4 numbers to the left, these 4 numbers, and we use those 4 numbers. So we're finding the median of the first half of the data. So there are 4 numbers there. 4 plus 1 is 5, divided by 2 is 2.5. So we're looking for the average between these two. So Q1 is equal to 1 plus 3, which is 4 divided by 2, which is 2. And we do the same thing for Q3 on the second half of the data. So here's the second half of the data. The middle right here. Q3 in this case is equal to 12. So the interquartile range is equal to 12 minus 2, which is 10. I wanted to show you what happens if you have an even numbers of data points. So the idea with the interquartile range is that we find the median, we find the middle, which happens to be this number, and then we look at the first half of the data and the second half of the data. Same thing happened up here at the top. We found the middle's here, so we do include both the 5 and the 6 in our values when we're looking at either half. So there's a description of how to find the interquartile range and how to make a box and whisker plot.